Welcome to another presentation on integrating testing into your development flow. Our focus of this series is to help you as a developer become more focused and aware of the test lifecycle, so you can develop software with testing in mind. Our hope is that by the end of this series, you'll start to implement some of these principal testing methodologies to your development cycle. As a result, you should be noticing an improvement in the quality of your code and an overall reduction in potential bugs and rewrites. With that in mind, let us get into today's presentation on integration testing. Before we start talking about integration testing, let's take a moment to quickly review what we have covered in the previous segments on integrating testing into your development flow. This series began with our initial topic of how to write testable code. This is where we highlighted a lot of testing methodologies and how they can be applied to the development process. We then followed up with the presentation on how to prepare software documentation to include testing, such as test strategy documents and test plans. Remember, a test plan deals with test coverage, features to be tested, features not to be tested, estimation, scheduling, and resource management, whereas a test strategy defines guidelines for the test approach to be followed in order to achieve the testing objectives and execution of the testing types defined in the testing plan. Once we have created these documents, the next process in the test cycle is to build unit tests. In that presentation, we covered how software can be broken into individual units or components to make them easier to test. We diverged from the testing cycle for a bit and actually dived into using a testing framework called TestNG to write these unit tests. In these lessons, we covered everything from basic annotations, building test suites, reporting, and using Selenium to expand our unit testing and getting into other testing areas like regression testing and automation. Finally, in our last presentation, we looked at how software patterns can also be applied to the testing process, such as modular testing, data-driven testing, key-driven testing, and behavior-driven testing. Which leads us to today's topic on integration testing, where we will be covering the following topics. What is integration testing? Why do we want to do integration testing and why it is so important? When do we want to do integration testing? Who does this type of testing? What are the different types of integration testing? How do we actually do integration testing? And finally, we look at some best practices. Let's start by defining what is integration testing. Integration testing is the next level of software testing after unit testing. The purpose of this level of testing is to expose faults in the interaction between integrated units. This is done by taking individual units and testing them as a group, using test drivers and test stubs to confirm if the different modules work as expected or when integrated together. Unlike unit testing, integration testing is not done by developers. Instead, testing is done by a team and is usually done before the system testing, and it comes after unit testing. In this stage of the testing cycle, testing starts to move from the developer to an independent tester or team, although that is not to say that some integration testing won't be done by the developer. It just won't be done to the same extent that we expected of them in the unit testing phase. Next, why should we do integration testing? Well, to start, in the real world, when applications are developed, they are typically broken down into smaller components or modules. These modules are then assigned out to individual developers. However, the implementation or interpretation by one developer can vary quite differently from another. So it becomes important to check whether the logic implemented by a developer meets the design expectations and is rendering the correct output in accordance with the requirements. Also, many a time the face or the structure of data changes when it travels from one module to another. Some values are appended or removed, which causes issues in the later modules. We also have modules that interact with some third-party tools or APIs, which also need to be tested, that the data accepted by the API tool is correct and that the response generated is also as expected. Finally, a very common problem in testing is frequent requirement changes. Unfortunately, because of this, many developers deploy their changes without unit testing them. This is why integration testing becomes so important. Otherwise, changes may go in that do not work or meet the desired requirement changes. So why is integration testing so often overlooked? Well, in many cases, integration testing is often overlooked because the business does not see it as a high priority. Instead, they tend to focus on testing areas like functional testing, cross-browser and cross-platform testing, or software localization testing to meet the demands of their customers. These areas are more visible and easier to explain to a customer than integration testing. Unfortunately, while these testing components are necessary and useful, they don't cover the extent of the software, and bugs tend to get missed. This is why integration testing really should be implemented to some extent, even if all your company wants to do is cross-browser testing. So what are some of the advantages of using integrated testing? Well, it ensures that integrated modules and components of the software are working properly. Integration testing can be started as soon as the modules are available. You don't have to wait until all the software changes are complete. And finally, integration testing helps to detect errors related to the interface. So what are some of the challenges that come with integration testing? Well, one, integration testing means testing two or more integrated systems in order to ensure that the systems work properly. Not only the integration links should be tested, but an exhaustive test of the environment should also be done to ensure that the integration system works properly. 2. Over time, managing integration testing will become complex. It all depends on the extent of your platform. For instance, you may have many factors to test like the database, platform, environments, and so on. 3. While integrating any new system with the legacy system, it requires a lot of changes and testing efforts. Same applies while integrating any two legacy systems. And finally, 4. Integrating two different systems developed by two different companies is a big challenge. Mainly, how will one of these systems impact the other if any changes are done in any of the systems? What are the different types of integration testing? Well, we have Big Bang, top-down, bottom-up, sandwich, and hybrid. Let's start with Big Bang. The Big Bang approach to integration testing is where we take some or all of the individual units and combine them together. Then we test them all at once. This typically doesn't happen until the development cycle has reached a release point or code freeze where the software is bundled up for release, which is great for smaller systems, but not so great when dealing with a larger software package. Because when an error is found during the integration testing, it is very difficult to localize the error. That's because the error may potentially belong to any of the modules being integrated, causing the debugging of any error reported during the Big Bang to be very expensive to fix. Next, we have top-down. As the name suggests, this type of integration testing starts at the top level, following the control flow or architectural structure. For example, starting from the GUI or main menu of your application. Components or subsystems are substituted by stubs, so we would test the top-level units first, and the lower-level units are tested step by step after that. Since some of the lower-level units may not be available during the initial phases, you need to create test stubs to simulate these units. Next, we have bottom-up. The bottom-up approach is the reverse of top-down. Here we begin testing the bottom-level units first, and the upper-level units step by step after that. Instead of test stubs, test drivers are needed to simulate higher-level units which may not be available during the initial phases. These drivers will drive and pass appropriate data to the lower-level modules. The primary purpose of this integration testing is each subsystem is to test the interfaces along various modules, making up the subsystem. Finally, we have the hybrid. The sandwich approach is a mix of both the top and bottom-up approaches. It is also known as the hybrid integration testing or mixed integration testing. In sandwich integration testing, the system is considered to be made up of 3 layers. The first layer is a layer in the middle, which will be the target of testing. The second layer is a layer above and below the target layer. And the third layer, testing begins from the outer layers and converges into the middle layer. Now that we know the different types of integration testing, let's talk about how we actually do integration testing. Well, to start with, we want to prepare the integration testing plan. Next, we want to design the test scenario, test cases, and test scripts. Third, we want to execute the test cases followed by the reporting of the defects. After that, we want to track and retest the defects. Once you hit the final step, you essentially repeat steps 3 through 4 until the completion of the integration is successful. It all starts with the test plan. As we covered before, a test plan is a document describing the scope, approach, resource, and schedule of intended test activities. It identifies, amongst other test items, the features to be tested, the testing tasks, who will do each task, the degree of tester independence, the test environment, the test design techniques, entry and exit criteria to be used, and the rationale for their choice, and any risk requiring contingency planning. It is a record of the test planning process. When building your test plan, make sure you include things like the test plan identifier. Remember, the test plan identifier provides a unique identifier for the test plan itself, its level, and the level of software it is related to. Next, include an introduction. The introduction is where we state the purpose of the plan, possibly identifying the levels of the plan. For instance, is this a master plan or one of the many possible phase plans? References. While not mandatory, it is a good idea to include a reference section that refers to other project-related items, plans, or documents which contain information relevant to the project. This section will contain a list of the related documents with links to them if available, including the following: project plan, quality assurance plan, configuration management plan, project specifications, business documents, relevant policies and standards, or reference higher level plans. Next, include some test items. The test items section contains things you intend to test within the scope of this test plan, essentially a list of what is to be tested. This can be developed from the software application test objectives as well as other sources of documentation and information such as the requirement specifications, design specifications, user guides, operation manuals or guides, and installation manuals or procedures. Make sure to include features to be tested. This is a listing of what is to be tested from the user's viewpoint of what the system does. This is not a technical description of the software, but a user's view of how the system functions. It is recommended to identify the test design specifications associated with each feature or set of features. Features not to be tested. This is a listing of what is not to be tested from both the user's viewpoint of what the system does and a configuration management version control view. This is not a technical description of the software, but a user's view of the functions, such as identifying why the feature is not to be tested. There can be any number of reasons why you don't want to test a certain feature. What not to be included in this release of the software. What is the low risk? It has been used before and is considered stable. Will it be released but not tested or documented as functional part of the release of this version of software? Approach. This is your overall test strategy for this test plan. It should be appropriate to the level of the plan and should be in agreement with all higher and lower levels of the plan. Overall rules and processes should be identified. Item pass or fail criteria. What are the completion criteria for this plan? This is a critical aspect of any test plan and should be appropriate to the level of the plan. The goal is to identify whether or not a test item has passed the test process. Suspension criteria and resumption requirements. Know when to pause in a series of tests or possibly terminate a set of tests. Once testing is suspended, how is it resumed and what are the potential impacts if the number of tests of defects reaches a point where the remaining test has no value? It makes no sense to continue the test if too many tests have failed. Test deliverables. These items need to be identified in the overall project plan as deliverables and should have the appropriate resources assigned to them in the project tracking system. This will ensure that the test process has visibility within the overall project tracking process and that the test tasks to create these deliverables are started at the appropriate time. Any dependencies between these deliverables and the related software deliverables should be identified. If the predecessor document is incomplete or unstable, the test products will suffer as well. Testing tasks. There should be tasks identified for each test deliverable, including all inter-task dependencies, skill levels, and so on. These tasks should also be corresponding tasks and milestones in the overall project tracking tool. If this is a multi-phase process, or if the application is to be released in increments, there may be parts of the application this plan does not address. These areas need to be identified to avoid any confusion should defects be reported back on those future functions. This will also allow the user and testers to avoid incomplete functions and prevent waste of resources chasing non-defects. Test environment. Are there any special requirements or infrastructure required for this test plan, such as, is there any special hardware such as simulators, static generators? How will test data be provided? How much testing will be done on each component of a multi-part feature? Special power requirements? Specific versions of other supporting software? Restricted use of systems during testing? What type of tools purchased or are created that need to be tested? Communications, web, client servers, networks, topology, internal, external, bridge routers, and finally security. One area that is often overlooked is estimate. In this section, you need to break down and provide a summary of the test estimates and/or provide a link to the detailed estimations. There are many elements to be considered for estimating the effort required for testing. It is critical that as much information as possible goes into the estimate as soon as possible in order to allow for accurate testing planning. Schedule. Scheduling should be based on realistic and validated estimates. If the estimates for the development of the application are inaccurate, the entire project plan will slip and the testing is part of the overall project plan. As we all know, the first area of a project plan is to get cut when it comes to crunch time at the end of a project is the testing. It usually comes down to the decision, let's put something out even if it doesn't really work all that well. And as we all know, this is usually the worst possible decision. And lastly, make sure you include staffing and training needs. In this area, you want to identify all critical training requirements and concerns. Here's a list of steps to help kickstart your integration testing. Start by understanding the architecture of your application. Then identify the different types of modules. Then understand what each module does. Also understand how the data is transferred from one module to another. And then understand how the data is entered and received into your system. Segregate the application to suit your testing needs. Identify and create the testing conditions. Take one condition at a time and write down the test cases. Another thing to consider before you begin your integration testing is the entry and exit criteria. This criteria will help define and set up what is to be tested and what results you should get from your testing. Let's start by looking at some entry criteria. Here we have things like unit tested components and modules, all high prioritized bug fixes enclosed, all modules to be code completed and integrated successfully, integration test plan, test case, scenarios to be signed off and documented, required test environments to be set up for integration testing. Next, let's look at the different types of exit criteria we can have. Starting with successful testing of integrated application, executed test cases are documented, all high prioritized bug fixes are closed, technical documents to be submitted followed by release notes. Now that we have a better understanding of what integration testing is, let's take a look at a real-world example. So here we have a company that wants to develop an online shopping site to sell merchandise related to the BBC show Doctor Who. After requirements gathering, analysis, and design was complete, they decided to hire some developers to develop each of the modules below. 1. A user registration and authentication login page. 2. A product catalog. 3. A shopping cart page. 4. A page for billing. 5. A payment gateway integration system for credit card payment, bank account payment, and so on. 6. A shipping and package tracking page. After each module was assigned to a developer, the developers began coding the functionality on their individual machines. They deployed the respective modules on their own machines to see what worked and what didn't as they went about developing the module. Once the development was complete, the developers tested their individual functionalities as part of their unit testing and found some defects. After the defects were fixed, they felt their modules were complete and the code was submitted. At this point, the QA manager suggested that integration testing should be performed to confirm that all the modules work well together. When they deployed all of their code in a common machine, they found that the application did not work as expected, since the individual modules did not work well together. There were bugs like after login, the user shopping cart did not show items that had been added earlier, the bill amount did not include shipping costs, and so on. In this way, integration testing helps us identify, fix issues, and to ensure that the application as a whole works as expected. Next, let's look at some tools we can use for integration testing. First, we have JUnit. JUnit is one of the most popular testing frameworks for Java programming language. It's very useful because it has a lot of extensions and has a lot of online examples, making it easy to find solutions to your problems. TestNG. This is another popular testing framework for Java. However, unlike JUnit, TestNG offers a large set of tools and extensions that go beyond just unit testing. Mockito. Mockito is the most popular mocking framework for writing unit tests. I like it because it has a simple API, a lot of useful features, and excellent documentation. For a more enterprise solution, we have Rational Integration Tester. IBM Rational Integration Tester is a scripting-free environment for developing tests for service-oriented architectures, messaging, and business process integration projects. Protractor. Protractor is an end-to-end test framework for Angular and AngularJS applications. Protractor runs tests against our application running in a real browser, integrating as a user would. And finally, we have Tessie. Tessie performs automated dynamic module unit and integration testing of embedded software and determines the code coverage along the way. Next, let's look at some best practices. 1. Determine the integration test strategy that could be adopted and later prepare the test case and test data accordingly. 2. Study the architectural design of the application and identify the critical modules. These need to be tested on priority. 3. Obtain the interface design from the architectural team and create test cases to verify all the interfaces in detail. Interface to database external, hardware software, applications must be tested in detail. 4. After the test cases, it's the test data which plays the critical role. 5. Always have the mock data prepared prior to executing. Do not select test data while executing the test manually. This brings us to our final topic of the day. Should integration testing be automated? Since many companies are becoming more and more concerned with continuous integration testing or automation testing, I thought this would be a good time to cover some of the pros and cons to consider before jumping on the automation train. For starters, integration testing automation needs an even more detailed approach. On the one hand, automated scripts reduce the QA time. On the other hand, automated tests are effective only when dealing with continuous or at least predictable datasets. With subscriptions, it is not often the case. The data is updated regularly and randomly, therefore the testing will be mostly manual. Automation is typically put into practice at the later stages of a project. That is because we have a lot of questions we need answered first. For example, what test cases do we need to automate? What are the key business processes that were selected? Also, each business process had a number of variations written. Only the test cases that covered the most stable business processes need to be automated. And finally, with such an approach, automation guarantees maximum coverage at optimized costs. Do we have any questions?
Yeah, I do have one. Michael, so how do, like, for instance, if you're a developer and you don't know, like, because integration at home is like combining different units. So how do developers test it? Do they test it like behind the scenes, or do they do they have to know pretty much the workflow? So
from the developers, when they do their unit testing, they're testing their actual code.
Mm-hmm.
So they're testing the code's functionality. They're not necessarily worried about testing the full end-to-end of the application.
Mm-hmm.
And that's where the integration testing comes in. This is where you do that full end-to-end testing.
Okay. So the developer shouldn't worry about the integration, isn't it? You just pushes his code, then QA can deal with it.
In most software shops, that's typically what happens.
Okay. Got it. Thank you.
You're welcome.
That being said, I've been to a lot of places, especially with larger software, where the developers are at least a strong part of the system and integration testing. And in some cases, unit testing is just step one. It's just the first piece to make sure that the units of code work. But then there is some additional work that's done. Now, usually the developers don't actually do the testing as much, or at least, I guess, create the testing, because this is really where you start, you get into a need for testing tools and things of that nature that, unit test, the stuff that we do for like, a JUnit or NGUnit or something like that, just don't have they're not a developer. They don't have that kind of a developer sort of tool for doing the testing. So they'll get in and they have to have some knowledge of it. But that's, again, it sort of depends on what level developers you're talking about. And usually if you've got a larger team, that means you've got at least a couple of architects or senior developers or something like that, that really that is part of their responsibility, is making sure that all of the pieces integrate properly, tracking down integration related issues, and then parsing that out and assigning that out to the people that need to make the appropriate changes.
Yeah, I see that a lot. Problem I see a lot, though, with some of the organizations using basically foregoing the testing teams and relying on the developers to do a lot of the testing. You still run into that phase where they forego the integration testing and they do more focused testing, like the cross-browser testing, or they just test certain components. It's really hard to sell some of the larger companies, especially if they're pushing out code so fast to meet their customer needs, to actually take the time and stop. So they're generating so much code that they have to test that functionality, get out the door. And a lot of times they forget, or they don't really walk through the application as a user would. They're focused only on, what was the business needs, what was the requirement, and that's what gets tested. So that's typically why you want to have a QA group and why you want to do the integration testing, because you want to make sure that you treat the system from a user perspective with the requirements and business documentation in front of you to make sure that it's doing what it's supposed to.
Yeah, agreed. The places I've dealt with where they've got the developers are involved, they're more like the hands and feet, where the QA team, or at least when it's done right, where the QA team really drives the actual test scripts and what's actually tested, because of exactly the points you brought out. And also, I think that system testing is an area where developer groupthink or myopia or whatever you want to call it, where you just get, as a developer, you get focused on the code and how you see it, how you're solving the problem. And the users, who have a completely different mindset, are going to use stuff probably very differently from what a developer thinks. And while unit tests are close enough to the code that a developer, I think, can be, for the most part, should be able to be trusted to build effective unit tests. Once you get up to the system integration piece, I think it's you need to have that outside specialist, I guess, which would be a QA resource or a team that really drives that from the user perspective. And I think that also sort of points to what you're talking about from the idea of trying to automate some of the system testing and integration testing. Is I think that's where that runs into something that it would make sense for developers. They're cranking out all this code to at least have some sort of way to, and we see this in continuous integration, continuous deployment a lot, where they've got some sort of way to kick off an integration system test of some sort to really just do, if nothing else, a smoke test or a sanity check on their latest, whatever the latest changes were.
Exactly. Any more questions?
Let's review. So today we talked about integration testing. We discussed that integration testing is a level of testing that is designed to expose faults in the interaction between integrated units, as well as taking place after unit testing, but before system testing in the software test cycle. Then we went on to discuss when and why we should do integration testing. For instance, many development cycles encounter scope creep and end up developing to the release deadline. In these cases, it is imperative that you have some type of integration testing in place. Otherwise, you run the high risk of releasing buggy code. We also covered that while unit testing is typically done by the developer, in the case of integration testing, most of the testing will be done by a QA manager or test team. Then we went on to discuss the different types of integration testing, such as the Big Bang, top-down, bottom-up, and the sandwich hybrid approaches, followed by how to do integration testing by looking at a real-world example. Finally, we looked at some of the best practices you should consider with your integration test processes. Thank you. I appreciate your time and would love to discuss any of this further. You can send us questions, comments, and suggestions through any of these following methods: info@developernerd.com. You can contact us on our website at developernerd.com/contact us. We're also on Twitter @developernerd. and we're on Facebook at facebook.com/developer. We also have a new YouTube channel that you can find the link on our main page. Our goal is making every developer better. Thank you, and have a